Have you ever looked at a massive ship and noticed that bold red line cutting through the water? It's on cargo ships, cruise liners, tankers, almost every large vessel on Earth, and it looks intentional. But here's the strange part. It has nothing to do with style, nothing to do with visibility, and definitely nothing to do with scaring off sea creatures. That red paint exists for a reason far more brutal, because without it, ships would slow down, break apart, and quite literally get eaten alive from below. So why red? The answer goes back hundreds of years, to parasites, chemistry, and one of the oldest battles in maritime history. The moment a ship enters the ocean, it's no longer alone. It becomes a target, not for pirates, not for storms, but for something far smaller and far more persistent. Within hours, microscopic organisms begin attaching themselves to the hull. Algae spreads, slimy layers form, then come barnacles, shellfish, and one of the most destructive creatures in maritime history, the shipworm. Despite its name, the shipworm isn't a worm at all. It's a type of mollusk that burrows into wood and eats it from the inside out. For early wooden ships, this was a nightmare, because once these organisms take hold, they don't just sit there. They multiply rapidly. This process is called biofouling, and it transforms a smooth, fast-moving vessel into something heavy, rough, and slow. The drag increases, the weight builds, the ship struggles to move efficiently through the water. In extreme cases, ships could lose up to half their speed, and in an era where speed meant survival, whether escaping danger or winning trade routes, that kind of loss wasn't just inconvenient, it was deadly. Sailors weren't just fighting the ocean, they were fighting the life inside it, and they needed a solution. Today, ship technology has evolved far beyond those early days. Modern anti-fouling coatings are incredibly advanced. Scientists can now design paints that are more effective, more durable, and even environmentally safer than older formulas. And most importantly, they can be made in almost any color. Bright blue, jet black, even neon green. So technically, ships no longer need to be red. And yet, most of them still are. Part of the reason is tradition. Maritime culture is one of the oldest in the world, and it holds on to its history tightly. Practices that proved reliable over centuries aren't easily abandoned. The red hull became a symbol of protection, performance, and trust. And that legacy still carries weight today. But there's also a very practical advantage. That sharp contrast between the red bottom and the upper hull creates a clear visual line across the ship's side. This makes it much easier for crews to monitor how deep the vessel is sitting in the water. And that matters more than most people realize. Ships are loaded based on strict safety limits. If they sit too low, they become dangerously heavy and unstable. This is measured using markings known as the plimsoll line, a set of reference points that show whether a ship is safely loaded. The red paint helps make those markings instantly visible, from a distance, in rough conditions, in real time. So while the chemistry may have evolved, the color stayed, because it still does its job, not just protecting the ship, but helping keep it safe. By the late 1700s, shipbuilders were running out of options. Wooden ships were being slowed down, damaged, and in some cases, completely destroyed by the life growing beneath them. Cleaning the hull manually was slow, expensive, and only a temporary fix. They needed something permanent, and that's when they discovered copper. At first, it sounded almost too simple. They began attaching thin sheets of copper directly to the bottom of wooden ships, and almost immediately, something remarkable happened. The marine life stopped sticking. Barnacles couldn't attach. Algae struggled to grow. And the shipworms, the creatures that once drilled through hulls, were suddenly gone. The reason comes down to chemistry. When copper interacts with seawater, it releases ions that are toxic to many marine organisms. Not enough to harm the ocean in large scale at the time, but more than enough to create a hostile environment on the ship's surface. In effect, the ship became self-protecting, cleaner, faster, stronger. This innovation changed everything. Ships could travel longer distances without slowing down. They required less maintenance. They became more reliable in both trade and combat. For the first time, sailors had a real defense against the ocean itself. But this solution didn't last forever. Because as technology moved forward, ships themselves began to change. As shipbuilding entered the Industrial Revolution, everything changed. Wood was replaced by iron. Then iron gave way to steel. Ships became larger, stronger, and more advanced. But there was a problem. The copper solution that worked so well on wooden ships suddenly became dangerous. When copper is placed directly on iron or steel and exposed to salt water, it creates a chemical reaction, almost like a battery. This process rapidly accelerates corrosion, causing the metal hull to rust and weaken far faster than normal. In other words, the solution that once saved ships could now destroy them. So engineers had to adapt. Instead of attaching solid copper sheets, they developed a new solution: anti-fouling paint. A special coating designed to mimic the protective effects of copper without the structural risks. And the key ingredient? Copper oxide. This compound slowly releases copper ions into the water, just like the old copper plates did, preventing marine life from attaching to the hull. But here's the detail most people never notice. Copper oxide has a natural color, a deep, rusty red. That iconic red strip beneath ships wasn't chosen for design. It wasn't chosen for visibility. It wasn't chosen at all. It was simply the natural result of the chemistry protecting the ship. The color came from function, and over time, it became a global standard. So the next time you see a massive ship cutting through the ocean, take a closer look at that red line beneath it. It's not just paint. It's a solution born from centuries of trial and error. From a time when ships were literally being eaten alive beneath the waves. A simple chemical defense that evolved into a global standard. What started as a fight against tiny sea creatures became a defining feature of modern engineering. And even today, long after the technology has advanced, that red hull remains, not because it has to, but because it works. Because it tells a story of how humans adapt, experiment, and carry forward the solutions that once saved them. Thank you for watching. If you enjoyed this deep dive, don't forget to like, share, and subscribe for more hidden stories behind the world around you.